Okay, hi everyone. Welcome to the section of the course where we calculate the p-value. Okay, so this took me a while. It took me a long time to figure it out, and then what I had to do is go to ChatGPT and ask it to give me simple puzzles until I felt like, okay, I've got it. I've got the steps in my head. So now that I've done that, let's walk through it. So we're going to just start off with some of the terminology. We'll walk through getting the p-value in the same example as the textbook, and I hope it will help you to clarify it, but really don't feel like you are slow if it takes time. It does take time. Just give it the time. And I recommend ChatGPT to help with this. It's very, very helpful for giving you puzzles to practice with and breaking it down. And we'll have a look at how I got it to work for me, so you can do the same. Okay. All right. So we're looking at how a research hypothesis can be transformed into a statistical hypothesis. This is a formal expression of the research hypothesis, which enables us to test it. Okay. And this is about how we use the p-value for deciding if the results of your experiment are statistically significant or whether they're just due to chance. Okay, because remember, your sample is never going to be exactly right. There's always an element of chance, which shows whether it's random or whether it's statistically significant. Okay. All right. So let's get going. Okay, so the basic purpose of research, this is the kind of thing they're going to easily convert into a multiple choice question. All of these little sentences are really likely to come up in exams, I think. The basic purpose of research is to test a theory by establishing whether certain relationships exist among constructs. In other words, whether there's a causal connection. A theory is defined as a network of relations between constructs that has been validated by research. And a research hypothesis is a statement concerning a possible relationship between two or more such constructs that we're going to test in order to validate the theory. Okay. So theory, research hypothesis, and purpose of research. Purpose of research, test a theory. A theory, network of relation between constructs, validated by research. Research hypothesis, a statement concerning two or more such constructs that you want to test as part of the validation of the theory. So those three definitions fit together. Okay, so we're going to refine the research hypothesis until we get three things out of it. 1, a measurement for our constructs. 2, what is the population? And 3, what is how are they connected? What is the nature of the relationship? How are they related? What's the connection? Okay. All right, so once we've done that, we've got an operational hypothesis or a research hypothesis. Same. Remember, operationalize means to convert into something that can be measured with numbers. All right, so now we're going to convert the operational or research hypothesis into a statistical hypothesis. Okay, a statistical hypothesis looks for the p-value. So we're going to use, if we look at the textbook, this is a great example. Okay, do UNISA students have a higher IQ than the general population? So we know that there's a constant for the average population, average IQ in the general population, it's 100. And we know the standard deviation, okay? It's 15. In other words, 68% of the population is going to be between 85 and 115 in their IQ, okay? And 95 is going to be between 70 and 130. 95% of all people will have an IQ in that range. And 145, 3 standard deviations, 98% of the population is going to be within that range down to 65, okay? All right, so now we're going to go and look at the math. Oh, before we do that, let's look at how we write the hypotheses. We've got two hypotheses. One is the one we want to show is true. That we call our alternative hypothesis, or H1, sometimes written as H with a subscript of A. So you see the subscript in math, it's a way of saying this particular one, okay? So hypothesis 1. If you have another hypothesis, it's going to be hypothesis 2. If you have a third hypothesis, it's going to be hypothesis 3, H3, okay? Is that the average, the mean of the UNISA students is greater than 100, okay? So our hypothesis 0, our null hypothesis, null means 0, right? So hypothesis 0 is that there's no change. IQ of the UNISA students is equal to 100. It's exactly the same as in the general population, okay? That would disprove our theory that UNISA students are smarter than the general population, okay? So our equal, we're always going to use the equal with the null hypothesis. So whenever you're creating your null hypothesis and your alternative hypothesis, the equal symbol is always going to go with the null. In other words, no change. Okay, equal meaning no change, no difference. There's nothing going on here. This is just a random blip because the sample size was too small because of chance. Okay. So now let's go. So there's three ways you could write your alternative hypothesis. One is to say it's not equal to 0, there's a difference. It doesn't matter whether it's greater than or less than, there's a difference. The other way is to say it's greater than. Hypothesis 1, UNISA students are more clever than the general population. Okay, and you'll have a greater than symbol. The other is less than. UNISA students are not as clever as general population. That would be your third way of creating an alternative hypothesis. But in this case, we're looking at greater than, okay? So you do an experiment. Okay, now that you've written your hypotheses, you do an experiment and you test 64 UNISA students, okay? And you find that their average is 104, okay? The average in your sample is 104 out of 64 students. So now we're going to do 3 calculations. Let's see, let's have a quick look at the graph, because we're going to come back. I drew one with ChatGPT to scale, just because I found it hard to visualize when it wasn't to scale. You can ask ChatGPT to draw graphs for you, and it'll draw a couple of them a day, and then it'll say no more. Okay, so our mean, which we get from our population in general, is going to be 100. The mean is 100. Okay, there it is. So we want to know, the next thing we want to know is how big is our standard deviation in this graph. Now this graph is a special graph. It's not a graph of the average IQ in our sample, and it's also not a graph of the average IQ in our general population. It's neither of those things. What it is it's something very special. It is a graph of, I highlighted this on page 80 at the top. It is the distribution of the mean of these IQs as represented in the general population. Okay, so it's like a distribution of the mean of the IQs in a set of samples. Okay. So the more, and this is going to be different according to how many samples you have. So how do we get a standard deviation on this graph? How do we get this line here? Well, if you remember, okay, so let's see, we're on page 79, in the middle of page 79. Okay, so this is our first calculation. This is the first formula we're going to do. We're going to calculate our standard deviation or our standard error. This is one and the same thing. Okay, and it's written here as sigma x bar. Sigma x bar. Okay, can you see how the x bar is a subscript? That tells you we're looking for the standard deviation of the sample mean. Okay, because remember that the mean is written in two notations. One is sigma, this little thing, this O with a kaf, that's sigma, and this is x bar. It's the same thing, it's the mean, but one is for population parameter and the other one is for sample statistic. So we're getting that standard deviation or standard error, which is the line that I asked ChatGPT to draw here. That's our standard error. Okay, so we want, how big is that? Where does it fall on this whole graph? So to get it, we simply divide the sigma for the population, which we know is 15 because they've given it to us, over the square root of the sample size, okay, which is 1.875. So then, if you were to draw to scale, you could go back to your bell curve and draw a line exactly 1.875 away from the mean, which is here. Now that we've got that measurement, 1.875 is like our, what's my grade above? 1.875 is our now interval for our 3 standard deviations to the left and 3 standard deviations to the right. Okay, so we can draw all of these lines. We say this is 1.875, whatever it is. This is the same distance again. That's 2 standard deviations. This is the same distance again, 3 standard deviations. Okay, so it'll be 1.87. 1.87 times 2 is 3.74, 103.74. 3 standard deviations is that plus 1.87 again. Lower IQ, 1 standard deviation on this chart is 98.13, minus 1.87, 96.26, minus 1.87, 94.39. So there we are, to scale. Okay, so we've done our first calculation. We've calculated this distance, 1 standard deviation or 1 standard error. Now we're going to do our second calculation. The second thing we want to know is our Z number. This is the Z axis. Remember that? This is because this is a Z chart. So this axis here is Z. It's the Z axis. So we want our Z value. We want to know how many standard deviations away from the mean is this number 104. Because we've got 104 is the result of our experiment. We found, oh, the UNISA students have an average IQ of 104. So how many standard deviations is that? Is it 1? Is it 2? Is it 3? How many is it? We don't know how many it is. I mean, you can see how many it is here because I've visually drawn it to scale. But to get this as a mathematical number, which would also enable you to know where to put it on this diagram exactly, we do our second calculation. And our second calculation is in the middle of page 80 in the textbook. Okay, here it is. that Z scale is the number in the experiment, X, okay, the outcome, less the mean. So we want to know the difference. We want to know how many, how long is that line from here to here. And so we take that number minus that number to say, oh, it's 4. Okay, that is 4. So that's what we're doing. We're getting that distance, 104 minus 100. And then we're going, okay, well, how many intervals is that? We know our interval is 1.87, right? So to divide that number by the number of intervals to get how many intervals is that? How many standard deviations from the norm is 104, okay? And the answer to that, here it is written with slightly different mathematical notation, but it's the same information, okay? The answer to that is, oh, it's 2.133 standard deviations from the mean, which you can see in the picture. It's 1, 2 and a little bit, which turns out to be 2.133. Okay. 1, 2 and a little bit. So now we've got that number. That's our second calculation. We've got our Z value. So we went, first we got our, what was it called? It was called our sigma, okay, our standard deviation. First we find our standard deviation on that special chart of the mean of the IQs. Then we want our Z value for that mean. Now we want our P value. So the P value, we don't have to calculate it because in the appendix D, on page 1, around about page 164 is the beginning of our chart where we can go and find the P value, okay? So if our standard deviation, our Z value is 2.133, you just go down, it's the furthest on the left, 2.133. Okay, so this is on page 166, roughly 2/3 of the way down. And we can go, okay, 0.0166, okay? Which is, if we look here, it's this area here, 0.166. And so that is how much of the probability range, the sample space would fall into this outcome. Okay, so this area is less than 2% of the whole area under the curve. We're looking at the area under the curve and saying, this is a lot of space here compared to this. This is a tiny bit of space. This is like 1.5% of the whole thing, okay? Which is the exact number of p-value. Where is it? 166. There we go. 0.166. 1 2/3%. Okay, 1.67%. Okay, approximately. That's our p-value, which you write as p, the probability that the z-score of the mean of the sample is greater than 2.133 is 1.smidgen%. Okay, it's small. It's less than 5%, which is the p-value cutoff number. So we know that our null hypothesis is can be discarded. The terminology, thank you ChatGPT, I always forget, can be rejected because the chances that this result is from chance is tiny. It's less than 5%. That's all we need to know. Okay, so we can reject the null hypothesis and say, hey, our results show that we are brighter than the general population, most likely. Yay! good for us. And we need it to conquer this course. Okay, so having done that, let's celebrate and call that the end of this Zoom, this YouTube. Go to ChatGPT and practice. Now, one more clue with ChatGPT. Okay, I told it firstly in the cue that I gave it to get a decent set of tests was I said to it, ask me to calculate the p-value for 6 simple problems in which the sample size is greater than 30. Because where the sample size is smaller than 30, we have a whole different thing we're going to do later in the textbook, which is called a t-test, and we haven't got there yet. And I told it, before I did this second part, it gave me some really complicated formula that I'm sure is very good. But we want our standard error to be calculated as sigma over the square root of n, so that we don't have to get confused. Give the solutions at the end, so I can try and figure it out, and then I can scroll down and check if my answers are correct. Okay, and a few different problems just to repeat it because it's like a language, so you need to repeat it to develop fluency so that you don't have to think when you're retrieving terms and concepts and processes. Okay, and because you'll find that you'll forget it as you learn it, so don't feel like you're abnormal or that this is unusual. It's really part of the process. Take your time, and I'll see you in the next video. Okay, good luck.